Let's consider why ancient wisdom matters. Cultures in earthquake-prone regions like Japan, China, Peru, and the Mediterranean developed building methods over centuries that allowed structures to survive tremors. These methods often relied on observation, trial, and error, long before modern seismology existed. By studying these, engineers today can adapt low-cost, sustainable ideas to enhance modern designs. One key principle from ancient architecture is flexibility. Take traditional Japanese pagodas, for instance. These multi-story wooden towers, often centuries old, have survived countless earthquakes. Their secret? A central wooden pillar, called a shinbashira, acts like a spine, allowing the building to sway rather than snap under seismic stress. The floors are loosely connected, so they move independently, absorbing shock. Modern engineers have taken inspiration from this, designing high-rises with flexible cores or tuned mass dampers, essentially giant pendulums that counteract swaying during quakes. Another example comes from ancient Inca architecture in Peru. Structures like Machu Picchu use a technique called ashlar masonry, where stones are cut so precisely they fit together without mortar. The stones can shift slightly during an earthquake and settle back into place, preventing collapse. This interlocking system inspired modern base isolation techniques, where buildings sit on flexible pads or rollers that absorb seismic waves, letting the structure float during a quake. In ancient Greece and Rome, builders used a method called opus caementicium, a type of early concrete to create durable structures. They mixed volcanic ash with lime to make a material that could flex under stress. Some Roman buildings, like aqueducts, still stand in earthquake-prone areas because of this. Today, engineers use reinforced concrete with steel rebar, but the concept of a slightly flexible, durable material echoes that ancient approach. Then, there's the use of lightweight materials. In ancient Himalayan regions, like parts of Nepal, traditional homes were built with timber frames and lightweight stone or mud walls. These materials reduce the risk of heavy debris causing injury during a collapse. Modern architects sometimes mimic this by using lightweight composites or timber in seismic zones, balancing strength with reduced mass. Another piece of ancient wisdom is site selection. Many ancient cultures avoided building on soft soil or near fault lines, favoring bedrock or stable ground. For example, some ancient Chinese cities were planned with earthquake risks in mind, using divination to pick auspicious sites, often just stable geological locations. Today, geotechnical surveys confirm the importance of building on solid ground to minimize amplification of seismic waves. We also see damping techniques in ancient designs. In India, some temples used layers of sand or loose gravel beneath foundations to absorb vibrations. This is strikingly similar to modern seismic dampers, which use springs, pistons, or even viscous fluids to dissipate earthquake energy. Now, blending these ideas with modern tech isn't just about copying the past, it's about adaptation. Ancient methods often relied on local materials and manual labor, which kept costs low and maintenance simple. Modern earthquake-proof designs incorporate sensors, computer modeling, and materials like carbon fiber, but they can be expensive. By combining, say, the Inca's interlocking stone concept with modern base isolation, you get cost-effective resilience that's easier to implement in developing regions. There are challenges, though. Ancient techniques were designed for smaller, simpler structures, not skyscrapers or sprawling urban centers. Scaling up requires testing and tweaking. Plus, some ancient methods, like heavy stone walls, don't always meet modern safety codes or energy efficiency standards. Still, the core ideas, flexibility, energy dissipation, stable foundations, remain incredibly relevant. In practice, you see this fusion in places like Japan, where new buildings often use a mix of traditional inspired flexibility and cutting-edge tech. Or in retrofit projects, where old structures are upgraded with dampers or base isolators while preserving their historic design. It's a balance of respecting what worked for centuries and leveraging what we know now. So, in summary, ancient wisdom offers principles like flexibility, strategic site selection, lightweight materials, and energy-absorbing designs that still hold up. By combining these with modern materials and engineering, we can create buildings that not only survive earthquakes, but do so sustainable and affordably. It's a powerful reminder that sometimes the past has answers we're still catching up to.